Was kann ich? Ja, ich habe hier noch ein Problem, glaube ich, mit der Auflösung. Uiuiui. Okay, ich beeile mich. So, besser. Okay, hi, I presented last year here, I think it was last year, about the OLSR mesh routing daemon. Basically, I wanted to give you a brief feedback, an update on what's happening, and we'll probably ask you for your support again. So last year I presented a pretty ambitious program to continue to work on the OLSR mesh routing daemon, which is, I think we can say, the first mesh routing daemon used in a wide sense in Freifunk and Funkfeuer and all the community Wi-Fi mesh networks. So what did we look at last year? Lots of code cleanup, performance improvements, a synchronization algorithm, and multipath routing. And the multipath routing had a question mark last year already. It proved to be true because we didn't get there yet this year. So there was lots of code cleanup. Next page. So what did we achieve compared to that? The code is much cleaner now. I encourage anybody who wants to use that mesh routing daemon to take a look at the code now and improve on it and see. It's pretty much readable. It's really fast now. There have been some great updates by Sven-Ola Tüke and others who are just squeezing out the last performance bits, and so we're very proud now to say that this runs on a 30 megahertz embedded webcam in the Freifunk network. That's roughly, I don't know how many 100 nodes, 800 nodes now or so, something like that. So it's really fast. There was some great work by Henning Rogge. I don't know if he's here in the room. And he was working on a metric plugin. So one of the big research topics in mesh networks is in 2008 was using different metrics, because when you want to find the best path to some other router, you need to define what's best. So that's the metric, that's the link cost. And it proved that the ETX extension, which was used or which is used in Freifunk, is only part of the truth. It minimizes the amount of hops and it minimizes the packets. So there is some great opportunity here for 2009 to improve on that, because now we want to also look into how we can choose paths based on the maximum capacity, bandwidth-wise, and least drop packets and lowest latency, etc., etc. So in order to make that, there is this metric plugin now where we can experiment with different metrics, and extra, Henning also programmed something that you get this layer 2 info from Wi-Fi cards up into higher protocol layers. Any mesh routing protocol or any protocol which wants to use that will be able to access Wi-Fi statistics in a transparent way for the MAC 802.11 Wi-Fi driver in Linux 2.6.29 probably. Next one. Okay. So multipath came later. That's for maybe 2009, 2010. We're starting to think long term now. And here's still a few things which were cleaned up in the code, lots of mallocs. Timers are much more efficient. And finally, Sven-Ola worked on some doku, so you can read and catch up on that. So one of the problems that we have is we need better bug reports. And one of the things that we noticed also, we need to test better before we release it on the Freifunk networks, because there were some voices which complained about, you know, code quality. It's still, so the tip is much, much better now than actually the stable branch. We believe that the tip is more stable than the stable branch. So, but we need your feedback for that. That's why I'm talking here also. We need good bug reports. And that means if somebody needs to go into GDB and look why the thing core dumped, please send that. Okay, that's it. The other talk, I want to briefly give you an intro of what I'm doing at work, actually. I started a new job in 2008. I work at the Austrian Registry, and we started to look into IT security. I want to give you a brief intro on that, and maybe also like later, if you want to talk with me about that, I would be very interested in your feedback. So we came across a botnet, which, funny enough, came on a USB stick. The infector came on a USB stick, no name, from China. You plug it into Windows. It comes from China. It connects to China. So it's a simple botnet, you know. It's an ISC server-based thing. You just have to sniff the password and you're in. Yeah. So what we got, Ivan Klimek from Slovakia told us that, and he analyzed it a bit, and we thought, oh great, let's go in and let's loot it. Huh? Let's take a look at that botnet. And we were really scared. You know, it's like a million infected PCs worldwide. We at Certity we produced statistics on that, informed the ISPs that, you know, some of their clients might be like 250,000 IPs in Mexico might be infected. We came around a problem which is, if any of you has a solution for that, I'm very interested, because when infected PCs are behind a NAT or dynamic IP addresses, it's not so easy to count how big is the botnet actually. Yeah? So counting botnets proved to be somewhat of a challenge. So I analyzed, like here on the right hand side you can see the number of IPs, and the y-axis is the number of logged in clients, and you can see this is a log plot, so there's a long tail here actually. Good. You can see very nice, we observed, we monitored the nice diurnal patterns, so night and day. You can really see it here. And one of my pet projects now at work is to visualize all kinds of security incidents live, if possible, and map them and get a picture of how the internet actually looks, or the underground internet actually looks like. So in case anybody, if you have some ideas on how to improve on that, please, I would be very happy for feedback. Good. Do I still have some time? Yeah. Okay, then I want to talk briefly about something else that we could do as a registry as .at, which is really to analyze the Kaminsky's problems, also in live. Yeah? So brief recap. You heard most of you probably heard yesterday the talk by Dan Kaminsky. Like the recursive DNS servers are vulnerable to cache poisoning. So an attacker can poison the cache here and send back the wrong answer to the stub, to the client. And we found a very nice, again, a very nice metric which clearly separates good from bad, or patched from unpatched recursive DNS servers. You can see the formula up there. If you want it, I can give it to you afterwards. Very simple. It's basically counting how many port changes there are. And since we had the live questions as .at, we could see basically in real time who is asking .at top level domains, and we could monitor the number of port changes of those askers, of those recursive DNS servers. So this was really interesting to actually give back some data to Dan, and Of course, it's anonymized. Of course, we cut out the questions, the DNS names, which wanted resolution. But we could do some very nice statistics, and you can see in the beginning, thanks. Great. And in the beginning, you can see like 90. The score is on the lower, on the x-axis. So 1 is almost perfect, is patched, and 0 is unpatched. You can see in the beginning, almost everybody's unpatched. These are the DJB servers on the right-hand side. So over time, we could observe like how this got patched. In the beginning, we had the advisory, and there were some people who know something about security. These patched then. And then afterwards, people started to scream in the media, and the exploit came, and it got slowly patched. So it's really interesting to see that even when we know that there is a vulnerability, which is so well known as the DNS cache poisoning attack, the patch rate is really, really slow. We're here at 50%. Okay? So good news is the important DNS servers are to 90% patched, and there are many, many out there which are still unpatched. Okay, thanks.
Okay. Just one reminder for you, for those of you who haven't heard it, we have an extra session tomorrow. So the usual session will be at 11:30 for 1 hour, but we have an extra session in the evening at 8:30, 8:30. It will not be in this room, but it will be in Saal 3, in room 3, just right over there. And there's still a few empty slots, so think about it. Bis morgen, no? Okay. Okay, looks good. Okay, we have 10 more minutes for 2 talks. That should suffice. No?
Hi everyone, thanks for showing up. I'll start with Hackable One now. So I'm Pierre Ponchory, I'm working for Bestech, and this is a GNOME-based distribution for OpenMoko. So we're doing embedded software development, research and development in hackable devices, and I will explain briefly what are hackable devices and why they are cool. So we are a cooperative of hackers. We are working remotely from France and Germany for myself. And you are welcome to show up at La Cantine in Paris. We have a hacker space over there, which is also a co-working area. So you can register online, work there all day long if you want. You're all welcome. So hackable devices are basically hardware with open specifications. And if the specifications are not open, if you can open them yourself, you're welcome, and it's going to be a hackable device as well. So a few examples out there on the market. You can find the Sharp Zorus, which is sadly discontinued. Of course, the Linksys WRTs are more or less hackable, even if it was probably by accident. But nowadays, with projects such as OpenWRT, you can find dozens of access points which you can actually open up, where you can change the operating system, and that's basically what this is about. You can also do more stuff like tweaking the casing, using them in a different purpose than its original.